Getting from point A to point B. For most of us, it's something we just do, right? We don't even think about it. But what if that simple act was one of the biggest challenges you faced every single day? Well, let's dive into this incredible fusion of AI and human ingenuity that's creating entirely new ways for people to experience and navigate our world. Seriously, just take a second and think about that. Without sight, how would you find your way through a packed train station or a chaotic supermarket? The sounds, the textures, the crowds of people, it's a massive amount of information to process all at once. How would you even begin? And this isn't some small niche problem we're talking about. Look at this number, 2.2 billion. That's how many people around the world are living with some form of visual impairment, according to the World Health Organization. That figure is just staggering. It really drives home how urgent the need is for better tools and technologies to help people navigate independently. So, that brings us to our first big idea. For decades, the white cane and the guide dog, they've been indispensable. They are true symbols of independence. But technology is now offering a huge leap forward, taking us way beyond simple obstacle detection. Now, what's really fascinating here is the fundamental shift in what we're asking for. Traditional aids are brilliant at answering one crucial question: can I step here safely? But these new AI-powered systems, they're aiming to answer much bigger questions like, what's actually around me? What's the fastest way to get to the pharmacy? And what's that cafe I can hear off to my left? You see the difference? It's about moving from just avoiding obstacles to truly understanding your surroundings. Okay, so how does this tech actually work? I promise it's not magic, even though it can definitely feel like it. It's really just a powerful combination of a few key technologies working together perfectly. So let's open up this new AI toolkit and see what's inside. First up, you've got computer vision. This is basically the eyes of the whole operation. Using cameras and really sophisticated deep learning algorithms, the device can recognize everything from crosswalks and doorways to the tiny text on a product label in a grocery store. It's the part that translates the visual chaos of the world into structured, useful data. Next, we have SLAM. Now, the name sounds a little intense, but the concept is brilliant. Think of it like this. You're an explorer drawing a map of a new place as you walk through it, while at the very same time, you're constantly updating a "You Are Here" pin on that exact same map. This is so important, especially for indoor navigation, where your GPS just gives up. It lets the device build a memory of a space and know exactly where you are within it. So you've got the eyes and the map-making brain. But how does the system actually talk to you? That's where multimodal interfaces come into play. Instead of just one type of feedback, these systems communicate through multiple senses. Imagine a 3D audio cue that makes a landmark sound like it's actually coming from its real direction, or a gentle vibration in a headband that guides you to turn left. It's all about creating an intuitive, natural flow of information that doesn't overwhelm them. And this is how it all comes together in this constant, elegant loop. The system senses the world with its cameras. It processes that data using computer vision and SLAM, and then it communicates the important stuff back to the user through sound or touch. Sense, process, communicate. It's happening over and over in real time. It's a constant conversation between the user, the device, and their environment. Okay, so this isn't just theory or stuff that's stuck in a lab. Let's move on and actually see how this technology is being used right now by researchers and companies to create real-world solutions. Take Microsoft's Soundscape project, for instance. Its goal wasn't just to give you robotic turn-by-turn directions. Instead, it used 3D audio to create this rich, immersive soundscape of the world around you, calling out streets and landmarks as you pass them. The whole idea was to help the user build their own mental map and confidence, rather than just making them dependent on a voice telling them where to go next. And researchers at Johns Hopkins are taking this even further with something called semantic maps. Instead of mapping every single object, which would be information overload, the AI filters the world for what's most important. For example, in a busy cafe, it wouldn't list every single chair. It would just highlight there's an available table near the window. It cuts through all the noise to give you a much more useful understanding of a space. It's not about getting more data, it's about getting the right data. And all of this comes together in these really comprehensive systems like the proposed RoboGuide. This architecture shows you the whole picture. You've got the hardware layer at the bottom with all the cameras and sensors, then an AI layer doing the heavy lifting, an application layer for planning routes, and finally, the user interface that puts it all together. It's a complete, stacked approach to creating a true navigation companion. But here's the thing. Even the most brilliant technology on the planet is useless if people can't or just won't use it. And this brings us to a huge reality check. Making this stuff work is about so much more than just writing clever code. Developers are up against a whole host of real-world problems. Can the device handle bright sunlight or heavy rain? Is the battery going to last all day? Are you just overwhelming the user with way too much information? And maybe the biggest one, how does someone feel using the device in public? These are massive challenges that can make or break a product, no matter how powerful the tech is. And this quote from a Portland State University review just hits the nail on the head. You just can't design effective tools for a community without involving that community directly. Simulating a disability by putting on a blindfold doesn't even come close to capturing the lived experience, the skills, and the actual needs of someone who is visually impaired. So ultimately, success is completely impossible without a user-centered design process. This means involving visually impaired individuals from the very beginning, from the initial ideas all the way to the final testing. Their feedback, their insights, their expertise, it's not just helpful, it is absolutely essential. All right, so with that really important human-centric focus in mind, what's next? Let's move to our final section and take a look at where all this incredible technology is heading. Today, we have some really powerful apps and devices, but pretty soon, things like 5G and edge computing, which just means processing data right on the device instead of sending it away, will allow for even faster, more complex analysis without killing the battery. And looking even further out, imagine these devices talking directly with smart city infrastructure, getting real-time updates from traffic lights, buses, and even the layout of a smart building you just walked into. But of course, this powerful future also brings up some tough questions. For one, these devices collect huge amounts of personal location data, which, raises big privacy concerns. Then there's the issue of cost. If these life-changing tools are too expensive, they could create a digital divide where they're only available to the wealthy. These are the big, important conversations happening right now. Which leaves us with this one last critical question. The technology is advancing at an unbelievable pace. But true innovation won't be measured by processing power or sensor resolution. It's going to be measured by how well we design these tools with empathy, with inclusivity, and with a deep respect for the people they're actually meant to serve. How do we build a future where technology truly empowers all of us?